The objective of this experiment was to be able to read temperature, determine the static sensitivity, overall error, and overall time constant of a thermistor. The wet thermistor and thermometer are placed in a beaker of room temperature water on a hot plate. Both ends of the thermistor are connected to a voltage divider, which consists of a 10 kiloohm resistor. The divider is then wired into the jack, which records the measured voltage.
Ow! I burned my tongue on my hot cocoa. I wish there was a way to determine the temperature of my hot cocoa without burning my tongue every time.
You know, I think there is a way, with a thermistor.
Thermistor?
Yeah, all you do is you connect the ends to a voltage divider and you put it in the liquid and it measures the temperature.
So we're going to go over some design stage uncertainties for the wet thermistor. Using our regression, we calculated the zero drift error, the sensitivity error, and the linearity error, and then found the quantization error from the DAC. And then we combined all of these electrical components with the thermistor uncertainty for an overall uncertainty of 2.24 degrees Celsius. So now to go over some of the results that we got from this experiment. So for the static calibration, we found that the element is highly nonlinear. So we had to linearize it over 4 regions, so we have 4 different static sensitivities. And for the dynamic calibration, we did 3 tests and did a semi-log plot to find the time constant, and all time constants were about 1.5.
So our project operation was done in 2 separate kinds of calibration, a static calibration and a dynamic calibration. So our static calibration, we put the thermistor and a thermometer and a beaker of water and recorded the change of voltage in the thermistor every 2 degrees from 17 degrees to 100 degrees. And with this, we found the static sensitivity and the different errors in degrees Celsius. And for our dynamic calibration, we took the same thermistor, plunged it into boiling water 3 different times to find the impulse response in hot water and calculate time constants. So for our static calibration analysis, we had to do 4 different least squares regression because our results were non-linearized. And with this, we averaged our calculated sensitivities and also needed to average our zero drift errors and our linearity errors. So for our dynamic calibration analysis, we tested 3 different temps, plunged into the boiling water. We recorded the steady state that was reached for each, calculated a temporal step response plot, performed a least squares analysis, and then determined the time constant for each temperatures recorded, and then averaged them to be about 1.5.
In summary, the thermistor is accurate. They all reach steady state about the same time and measured with an accuracy of plus or minus 2.2 degrees Celsius.
Get your thermistor today!